So let's go to 3D. What is that in a 3D? 3D is about having an x coordinate, y coordinate and an z coordinate, correct? So you'll have 3 points x1, y1, z1 and x2, y2, z2. And the distance between the two is root of x2 minus x1 the whole square plus y2 minus y1 the whole square plus z2 minus z1 the whole square. It's very straightforward. Okay, that you know. Okay. Let's come to the point. In 3D, we have to write the equations of the line. The equation of a line, supposing if it contains one point and the direction has been given. Take the directions as b vector, which is ai plus bj plus ck. Okay, this direction, the direction cosines of the parallel lines or the directions. This point will be given, take it as x1, y1, z1, which is also known as a vector. So thus this point is x1, y1, z1, which is known as a vector. The direction of this line is given as b vector, which is a c and the direction cosines of it, small a, small b, small c. This a vector is a vector. These are the coordinates, this difference between them. So x minus x1 by a. Consider arbitrary point x, y, z and subtract this. X minus x1 by a, because they are parallel lines. Two parallel lines will be proportionate. X minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c is equal to lambda. This will be the equation of the line. See what happens if there is 2 points x1, y1, z1 and x2, y2, z2. In that case, consider arbitrary point x, y, z. So it will be x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. So this is the equation of a line. You can equate it to lambda if you want, because they will all be proportionate. So this is the equation of a line when you know 2 points. This is the equation of a line if you know one point and a direction. Okay. Let's consider this as r x, y, z be the r vector, therefore is equal to a lambda, which is all this is b vector, what is there, okay, and this goes the other side, a vector plus lambda times b vector, because a stands for x1, y1, z1, which goes to the other side, and this b vector stands for the denominator, which gets multiplied by lambda. So r vector is equal to a vector plus lambda times b vector becomes my vector form of representing a line. So in this case, it's r vector is equal to this x1, y1, z1, which is a vector, will go to the next side, plus this denominator is going to go multiplied by lambda times, what is this, b vector minus a vector. Considering this is b vector, consider this as a vector, it's b vector minus a vector, which is just the direction. So next is sum. So these are the equations of a line passing through one point and equations of a line passing through 2 points. Okay, so x minus x1 by a is equal to y minus y1 by b is equal to z minus z1 by c is the equation of line passing through a point x1, y1, z1 whose directions are given by direction cosine abc as b vector. R vector is equal to a vector plus lambda times b vector. Okay, so next suppose they asked me angle between two lines. Obviously this line will be passing through a point x1, y1, z1, which is a vector, and parallel to a vector b vector. Let's consider a1 vector and b1 vector. This will be passing through another point a2 vector parallel to another vector b2 vector. So you are not bothered about the point through which the line is passing. To find an angle, you just need that both the lines are a direction, which is just b1 and b2. So the cos theta can be written as b1 vector dot b2 vector by magnitude of b1 and magnitude of b2. That is cos theta, the angle between the two lines. So you just have to locate only the directions of the line and the points need not be considered. You know how will a line be? Imagine a line will be like this. A line will be what is it? R vector is equal to a vector plus lambda times b vector, and another line will be a1 and b1, a2 vector plus lambda times b2 vector. So you just have to spot what is coming after lambda, which will give you the direction alone, and just do that dot product by magnitude so that you get the cos theta. So that's how you find the angle between two lines. Okay, the points need not be considered. So that is about this, and if you know two lines are parallel, the direction ratios b1 and b2 will be proportional. What is b1 is got ai plus bj plus ck, correct? inside of it the b1 vector. Let's call it as a1, b1 and c1. This b2 vector, let's direction of the second line, let's call it as a2i plus b2j plus c2k. If you consider like this, okay, b2j plus c2k, I hope you are clear. Then in that case, they are parallel, it is proportional, the direction ratios will be proportional. a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Normally what comes as a coefficient of I, j and k are called direction ratios, DRs. They will be called as direction cosines if the squares of the roots a square plus b square plus c square become unity. That is when it is called direction cosine. Otherwise, it is only called direction ratio. Okay. So, what is next? Okay, with this you can look at the exercise which covers 3D straight lines and angle between lines and two parallel lines and two perpendicular lines. Coming back to two perpendicular lines, this line will have a direction b1 which will be present after lambda. If it is a vector form, if it is a Cartesian form, you can multiply and whatever is in the denominator will be your b vector, correct? X minus x1 by a, this will be your denominator and that will be your b vector. So, then two perpendicular lines, it will have a b1 vector and this will have another b2 vector as the direction, and you are not bothered about the line through which the point through which the line is passing, it does not make sense. So, b1 vector dot b2 vector will be equal to 0, that is a1i plus b1j plus c2k into a2i plus b2j plus c2k will be equal to 0. So, dot product panna, you know you can dot only i's and i's, a1 a2 plus b1 b2 plus c1 c2 is equal to 0 is the condition for two lines to be perpendicular, where you dot producting only the direction ratios of the line. Okay, so this completes all the line equation. Apart from that, they will ask you distance between two skew lines. Distance between two skew lines. What is that? It means the two lines are not lying in different planes. So wall la or line irukku, floor la or line irukku. Okay, floor la or line irukku. So these are two skew lines. They will never meet because they are two different planes, and they suppose they ask you the distance between them, that is the shortest distance between them. Therefore, when you join it, this will be perpendicular to this and this will be perpendicular to this, because this point has to be shortest to this point has, you have to locate that point which is shortest to both and join it. Okay. So the shortest distance between two skew lines, the diagram will be like this, because they are lying in different planes. It will be passing through a1 parallel to b1 or passing through a2 parallel to b2. You are joining this point, the points that you know is only a2 minus a1. You are joining a2 minus a1 and you are getting this vector, okay, which is a perpendicular vector, which has got to be a perpendicular vector. Yeah. If you cross b1 and b2, you get a vector which is perpendicular to both b1 and b2. So you take this a2 minus a1, which has to be perpendicular, therefore you multiply it with this. Therefore, it is a2 minus a1 dot b1 cross b2 by magnitude of b1 cross b2, because I only need the direction of b1 cross b2. So n cap is what I need, unit vector. So that vector by its magnitude. This will give me the distance between two skew lines and the whole magnitude. Because it will be magnitude only, you don't have to whole magnitude. Hope you understood. Do one exercise and come back to me for doubts before going to planes. Okay, finish the